Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Continuing with our topic of electrolysis. In part 3 we had mentioned 4 factors which affect the product of electrolysis, and we have already covered 2 in part 3, that is the nature of the electrodes and the electrode potential of the ions involved, or what is more specifically called as the reduction potential of the ions involved. In this particular lesson we are taking up the electrolysis of molten sodium chloride and the electrolysis of sodium chloride solution. And what type of solution is? It's a concentrated solution of sodium chloride, what is also called as brine, right? You will understand later why I am specifically mentioning concentrated solution of sodium chloride over here. These 2 factors will explain or will help us to explain another factor which affects the products of electrolysis, and that is the state of the electrolyte. Now we have got sodium chloride in both the cases, but in one it is in the molten form, that means only sodium chloride which is in the form of a liquid. In the other, sodium chloride has been dissolved in water. So let us see the products which are formed. We are going to concentrate on the theoretical aspect. We are not doing the electrolytic cells, we are not drawing. I would assume that you had enough practice of it in part 3. Sodium chloride, it's in the form of a liquid. When it ionizes, it forms, or when it is turned into the liquid state, so we'll have sodium ions and chloride ions. We talk about the cathode and the anode, so we will take inert electrodes over here like carbon in the form of graphite, cathode and anode. Actually, more specifically, when you talk about the commercial purposes, then we don't use carbon as the electrodes. There are others. We will, as I said, we are not going into the practical details of it. Cathode is negative rod, anode is positive rod. Cations go towards cathode, anions go towards anode, AACC. We have only one cation over here, so that rules. So it takes up electrons from the cathode and discharges as sodium metal. We know that sodium metal is highly reactive, so what is done is the sodium is actually collected as an amalgam. It is dissolved in mercury and collected. Anode, on the other hand, we have chloride ion which will go towards the anode. So chloride ion loses electron, forms Cl. We know very well from the study of chemical bonding and atomic structure that chlorine atom as such cannot exist independently. So chlorine combines with another chlorine atom and gives us a greenish yellow gas, that is chlorine. So when you are electrolyzing molten sodium chloride, you are getting 2 products over here, sodium metal and chlorine gas. Right? Now let us see how the products are affected when you add water, when you add a little water to the sodium chloride instead of melting it. Now sodium chloride is an ionic compound, it will dissolve in the water, and we have the 2 equations over here. Sodium chloride breaks down or dissociates to form sodium ions and chloride ions. Water also ionizes to give us hydrogen and hydroxyl, right? CCAA. Cations go towards cathode, anions go towards anode. Now there is a contender for this position. Earlier, sodium was whole and soul over here. Now it's got a competitor over here. We know that the reduction potential of hydrogen is 0 whereas the reduction potential of sodium, can you find out and tell me what is the reduction potential of sodium? Pause the video, find it out. I'm waiting for the answer. Giving me the answer? Yes, it's negative 2.71 volts. The value may differ slightly after the decimal position because it varies with the text sometimes. Now, if you notice over here, the reduction potential of hydrogen is much higher because this is a negative value compared to 0. This is a negative value, this is 0. So 0 is bigger than -2, right? So hydrogen has got more tendency to get reduced compared to sodium. So H positive is the winner, gains electrons, turns to hydrogen. H plus H gives you hydrogen gas. This burns with a blue flame, pop sound. So we've got at the cathode, hydrogen gas is liberated. What happens at the anode? Again, go back to the mnemonics that I had given you. According to that, hydroxyl ions should be discharging at the anode, right? If you remember, I brought the colors not safe for activity, right? That's what the mnemonics was. But you see, the word that I mentioned at the beginning of the lesson was concentrated. That means in this particular solution, the concentration of chloride ions is high. So although in terms of oxidation potential, hydroxyl ions should lose electrons, but because chloride ions are in the majority, they get an upper hand. So chloride ion loses electrons, forms Cl. Cl plus Cl gives me Cl2. So a gas is liberated, and that's the greenish yellow gas. Chlorine is liberated over here. We can show it by a small G in brackets in front of chlorine. So the product obtained at the anode in both the cases is the same, whether you talk about molten sodium chloride or concentrated solution of sodium chloride. Whereas the product obtained at the cathode changes, right? So if you notice over here, what is affecting the formation of the products is the concentration of the electrolyte as well as its nature. How concentration? How are we talking about concentration? There's nothing to do with concentration because this is not an aqueous solution, this is not a solution. So this, what I am saying, is it validated? No, right? So what we've got over here is the only factor that we have studied or discussed till now in this particular part is the nature of the electrolyte, in what form the electrolyte in. I need to justify this as well. How does the concentration of the electrolyte affect the nature of the products formed at each of the electrodes? So let's go to that. But before we go over here, something interesting. The sodium ions are there in the solution. The hydroxyl ions are there in the solution. So the sodium ions and the hydroxyl ions combine to give us sodium hydroxide, which is a very good cleaning agent and is used in a number of reactions. So if you notice, by electrolysis of brine, now sodium chloride is very readily available on the earth, in the sea, everywhere it is there, and it is being used to generate hydrogen, chlorine, sodium hydroxide. We are getting three products on electrolyzing a solution of brine. Now let us see what will happen if I increase the concentration of water compared to that of sodium chloride. Can you make a guess what will happen or what will be the product's form if water is much more compared to sodium chloride? Try going back to what we did in, I think, lesson 2, in part 2, where we did electrolysis of. Can you recall what did we do electrolysis of? It is two words starting with A and W. Let me see if you can recall. Going a step further. Electrolysis of dilute sodium chloride solution. Now when I am saying dilute, what I mean is that the proportion of water is much more than that of sodium chloride. So the equation is sodium chloride breaks down to give you Na positive plus Cl negative. Water ionizes to give you H positive and OH negative. CCAA, cations go towards cathode, anions go towards anode. So we've got a war going on over here, sodium and hydrogen. Who's the winner in the game? Yes, very clear. H positive electron gives us H, H plus H gives us hydrogen gas. Right? So if you notice, the product at the cathode is the same in both the cases where you are taking concentrated solution of sodium chloride or you are taking a dilute solution of sodium chloride. What will be the product obtained at anode? Now if you have not written so far, please try writing the products at the anode from your knowledge that you've gained by electrolysis of acidulated water. This was the hint that I had given you. Pause the video, try writing. If you are not able to write, then it's a wake-up call that you need to revisit the topic electrolysis of acidulated water. That's part 2 in this set of videos. You need to be very clear in that in order to proceed and in order to have a firm understanding of this particular topic. And I repeat in every video, please keep a pen and paper handy with you. It is very easy to sit and watch videos and understand, but it is a totally different thing writing down what you are understanding. Believe me, when I am just preparing for a video, in order to record a video, if I have not written the equation myself, I am not confident about teaching you guys. And that is where many a times I do make mistakes. I am accepting here. Nobody is infallible. We all make mistakes. But then I have learned from my mistakes and I try to write and then go ahead. Right? That gives me the confidence as well to face you all. Enough of those lectures. Coming back to anode. Hydroxyl and chloride. Who's the winner here? Come on, recall what we have done earlier. This is what I had devised and given you. Oh, I brought colors not safe for activity. Remember? OH negative, I negative, Br negative, Cl negative, NO3 negative, SO42 negative, F negative. And activity is for the activity series of anions. Right? You can devise your own sentence also, whatever you are comfortable with, whatever language you are comfortable with, so that you can relate to it. This is something that I devised impromptu and I am sharing it with you. So because the concentration of the chloride ions now is not so high, unlike when we have a concentrated solution, so here it is the hydroxyl ions which will turn to OH. Now OH cannot exist, so again we will have 2H2O plus O2. So what gas is liberated at the anode in this case? Yes, it is oxygen. Right? Whereas in the case of a solution of brine, the gas liberated at the anode was chlorine because their chloride ions were getting discharged. Now can we say that the concentration of the electrolyte affects the formation of the product or not? Yes, we can say. So we have covered all the 4 headings where we have discussed what are the factors which affect the formation of the products during the process of electrolysis. In part 3, we have also covered some of the applications. I am repeating some. We've not been able to cover all, but we've covered some of the applications of electrolysis. If you've been able to relate to this topic and would want to continue learning further with us, please don't forget to like, subscribe and share the channel. Pen and paper chemistry. Keep smiling and take care of your health.